right, in this section 11-2, we're continuing our unit in circles. And for this section, our topic is going to be arcs and angles. So arcs and angles that are involved with the circles. And so a few vocabulary words that we come to first here. If this is the circle that I have, and I've drawn a radius here and a radius here, then the first definition we come to is central angle. So a central angle is an angle whose vertex is at the center of the circle. So if we have an angle whose vertex is at the center of the circle, this angle is a central angle. All right, so angle BAC, that's a central angle. So can't forget about all the angle notation stuff that we learned last semester, angle BAC. Remember, the middle letter of the angle is the vertex, right? BAC. And the other letters kind of trace out where the angle is. So this is the angle right here, central angle. An arc is a piece of a circle. Kind of like a segment is a piece of a line, an arc is a piece of a circle. Okay? Now, we have different types of arcs. So we're going to spend the next few minutes developing and making sure we have an understanding of the different types of arcs that a circle has. A minor arc is an arc that's less than 180 degrees, and it's named with two letters. Okay, named with two letters. All right. So we're going to kind of go through all these, and then I'll give you some examples. Okay. All right. So minor arc is less than 180 degrees, named with two letters. A major arc is more than 180 degrees, and it's named with three letters. And you'll see why here in a minute. So 180 degrees is half the circle. So if it's less than half the circle, it's a minor arc. If it's more than half the circle, it's a major arc. And if it's equal to 180 degrees, it would be half a circle or a semicircle. All right, and that's also named with three letters. Let me see here. So let's talk about how to name these things correctly. So if I wanted an example of a minor arc, if I said, okay, look at arc BC. Arc BC is from here to here. That's arc BC. Is that arc more or less than half the circle? Well, BC, that arc would be less than half the circle, so therefore it's a minor arc. Okay? So notice, to name an arc, okay, you use the letters of the endpoints of the arc, then you must put the arc symbol over them. So remember last semester we have a segment symbol, a line symbol, a ray symbol, all that kind of stuff. All right, so now we have an arc symbol. So it's important that you use the correct symbol to make sure you're denoting the correct object. Now, just like with a segment and a line, the letters can be reversed. Arc BC is the same thing as arc CB. All right, they are the exact same object. They can be named either way, so it doesn't matter which order you go to name it. All right, so arc BC or arc CB is a minor arc. Now, if we want to talk about a major arc, if we talk about the arc from B all the way around the long way to C, because remember, from B to C, there's a short way that's a minor arc, but there's a long way that's a major arc. So if I go the long way around, okay, then that's going to be a major arc, because from B around to C, the long way is going to be more than 180 degrees, so therefore, it's more than half the circle, so it's a major arc. Now, here's where the three letters come in. If I wanted to name that arc, okay, then I would start off with one end, B. The next letter, the middle letter, has to be a letter in the direction the arc is going around, okay, and then the last letter has to be the other endpoint. Okay, so if I wanted to name the arc from B to C the long way around, I would call it arc BDC. Arc BDC, the long way around. Okay, now, or just like the last time, you could go in reverse. CBD is the same arc. Notice I still have the arc symbol above it. And as we mentioned, because it is more than 180 degrees, it's a major arc. All right, now, here's the next thing. Let's make sure we understand why it has to be three letters. Okay, here's the deal. Okay, if I just say, look at arc BC, right? If we did not establish the notation, then you would not know if I was talking about the short way around, the minor arc, or the long way around, the major arc. So the notation is, if it's only two letters, it has to be minor arc. And then so that if I just say, look at arc BC, you automatically know I'm talking about the short way around. If I want to denote the long way around, I I have to use 3 letters. So that way you know if you only see 2 letters, you're talking about the short way around, and if you see 3 letters, you're talking about the long way around. All right, so that's kind of the difference there. Semicircle, if I wanted to talk about the semicircle from point D over to point C, all right, I would call it arc DBC. So just like with a major arc, you need a letter in the middle, a point in the middle of the 2 letters that kind of shows you the direction the arc is traveling in. Here's the reason why you need 3 letters for a semicircle, because if I just said look at arc DC, you wouldn't know if I'm talking about the top half or the bottom half of the circle. And so that's why that 3rd letter is in there for semicircles, for arcs that are semicircles, because of the fact that you need to know which half of the circle that you're talking about, whether it's the top half, bottom half, etc. Okay? So that's just a few minutes about the notation of the different types of arcs that we have. And so make sure that when you're writing out an arc and denoting it, make sure you use the proper number of letters and make sure you put the arc symbol above those letters. And recognize you could go forward or backwards. All right? Now, here is another very important fact that is going to be relevant throughout pretty much the rest of this chapter. This is one thing that we need to make sure we lock down in our mind as far as being able to help us solve problems and whatnot. All right, so listen to this theorem. The degree measure of an arc equals the degree measure of its central angle. The degree measure of an arc equals the degree measure of its central angle. So just like angles are measured in degrees, arcs are also measured in degrees because they are a rounded type of object. All right. They can be measured in length, right? But they're also measured as far as degree measure as well. So the degree measure of the arc equals the degree measure of its central angle. So what we mean by that is if the measure of angle BAC is 60 degrees, then the measure of the arc, okay, that it goes to is also 60 degrees. So if this angle comes out and hits arc BC and the angle 60 degrees, then the arc also has to be 60 degrees. They have to match. All right? They have to match. It's got to be the same. So if this is 25 degrees, the arc's 25 degrees. If this is 82 degrees, the arc is 82 degrees. The central angle and the arc that it goes to, it has to match. All right? Now, let me say this too about the arc. It has a degree measure of 60 degrees, but it also has a length, and we'll get into that in a few sections later. So the degree measure of arc BC could be 60 degrees, but the length of arc BC could be 18 centimeters. See the difference? It's 2 different units of measure measuring 2 completely different things. So the degree measure of the arc and the length, how long the arc is 2 different things. Because I could have a small arc that's 60 degrees and is 18 centimeters, or I could have a really big arc that's also 60 degrees, but its length is 140 centimeters. You see the difference? All right, so make sure you keep that in mind. All right, so based on all of this background information, here's a look at the type of problems that we're going to be taking a look at here. All right, so on this one, they have given me the information that the measure of angle BAC is 48. So let's locate that and draw it on our diagram. BAC, 48 degrees. So based on that measurement, I've got to find the measure of all of the rest of these arcs that are listed. All right, so let's take a look and see how we are going to be able to do that. So the first one that I'm trying to find is the measure of arc BC. Where is the measure of arc BC? Well, arc BC is here. Now remember the statement that we just looked at, right? The measure of the arc is the same as the measure of its central angle. And so this 48 that we were given actually goes to that arc BC. So if the central angle is 48 degrees, then how much is the arc? Also 48 degrees is the right answer. All right, so there you go. Okay, what about, let me see. Which one do we want to look for next here? Maybe perhaps this one, DE. So let's look for DE. Okay, so here's arc DE, right? Here's arc DE. Okay, think about this. If this is 48 and this is 90, remember this, as far as the angles are concerned, all three of these angles would add up to 180 degrees. So if this is 48 and this is 90, then this one has got to be 42. Because if I do 180 minus 48 minus 90, I'm left with 42. And once again, if the central angle is 42, then the arc is 42. So that'd be 42 degrees there. What else we got? BF. Arc BF is from here to here. So once again, we'll utilize the fact that these two are a linear pair. They add up to 180. So if I do 180 minus 48, that makes this central angle 132. Remember, if you're trying to get the measure of the arc, if you can get the measure of its central angle, then you got it. And that's what we did here. These two add up to 180. 180 minus 48 is 132. So if the central angle is 132, then the arc that it intercepts is also 132. All right, so there you go. If you want the measure of the arc, get the measure of its central angle. All right, what about this one? This will be the first major arc that we've had. CBE. So it's the long way around from C around to E. So how are we going to figure that out? Okay, well, I know this is 48. I know this part's 132. If I had this part, I could just add them all three together and get the answer. All right, so the question is, how do I get this arc? Well, that question then becomes, how do I get this angle? Well, remember, one thing that we learned way back in the first semester many, many months ago is take a look at this angle and this angle. Remember, they're vertical angles. So we haven't heard that term in a very long time. Vertical angles. And vertical angles are congruent. So if this one's 48 degrees, this one's 48 degrees, which means this arc is 48 degrees. And now, if I wanted to get the measure of angle CBE, arc CBE, then I just need to add 48 plus 132 plus 48 and get 288. Okay? So again, there are ways to get all of the arcs, and then this one would be, of course, 90 degrees up here. Okay, what about CFB? CFB. So CFB. So the long way around from C to B, which is from here to here. Now, there are a couple of different ways that we can come up with this one. You could add 90 plus 42 plus 48 plus 132 if you wanted to, because we have all the arcs now. But that would be the long way of doing it. The short way of doing it would be all the way around 360 minus 48. So if we do 360 minus 48, then we get 312 as the degree measure of the arc. All right. So all the way around is 360. But if you take away that 48, you're left with 312. So the measure of arc CFB is 312 degrees. Okay, what about the last one that we have here? It's DBE. So DBE is all the way around this way, the long way around from D to E. Okay, long way around from D to E. Okay, and so we can utilize the same method as we did for the last one. All the way around is 360. This arc is 42. 360 minus 42 is 318, and then that is your answer. So the assignment that you will have, you'll be utilizing the different measures of the central angles and the corresponding arc measures to come up with the measures of different, the degree measures of different arcs in a figure. All right, and so this kind of gives you an example of some of the ways that we can do that, and you are now ready for your quiz.